Recitation Exercises of section 11.9. As you remember, Shabab, this section is about representations of functions as power series. So if you have a function like this is in fact the main tool that we are using in this section. 1 over 1 minus x is equals to sigma x to the power n, the power series x to the power n, provided, of course, that the absolute value of x is less than 1. From where this is coming, Shabab, it is coming from a over 1 minus r for this power series, which is a to the power r n minus 1. This is a geometric, a convergent, this is n طبعا, because we're starting from 0. This is a convergent geometric series that its sum is this. طبعا a is 1, r is x. And you know that the condition that the absolute value of r is less than 1. So in general, ya Shabab, you can generalize by the concept of substitution. You can generalize this for any function. If you have 1 minus y to the power n, y less than 1. So in general, if you have 1 minus a function that is continuous, then it is equals to the power series f of x all to the power n, provided that the absolute value of f of x is less than 1. I wish this is clear, Shabab, because if you understand this, you will be able to solve all the related problems to this section. The second part of the section is what it was about, integration and differentiation term by term. So if you have a power series that represented by this function, indeed, this function is representing the sum of this power series. And therefore, if the domain of this function, now this is a function, the domain of it is the interval of convergence. This one. It is the interval of convergence. It is the domain of that function. Now, to differentiate, you know that you will differentiate term by term. If you integrate, you can integrate term by term. The radius of convergence will be the same, but the interval of convergence, it may not be the same, especially at the endpoints for the derivative when you differentiate. So when you differentiate a power series, it is just about the power series of the derivative, which you know how to differentiate this. The Cn is a constant because you are differentiating with respect to x. So it will be n multiplied by Cn, x to the power minus a n minus 1. Similarly, when you integrate the power series, it will be the power series of the integral. You will integrate term by term. And when you integrate, this is a constant. It will be out of the integral. Then you will add 1 and divide by the new power. This is Cn طبعا. Cn the coefficient, not the multiplication. It is Cn. Okay, so next, I think we are ready now to start solving the recitation exercises. Think about this one, Shabab, in 1 minute, how to solve this. The question is find a power series. طبعا يا شباب, as I told you, it is not unique. You may have several, but usually we will try to get the standard one, centered at 0, of course, similar to the question number 1 formula. So we need to find the power series representation for this function, and then we need to determine the interval of convergence. Remember your tool, ya Shabab, the tool that we have is this. 1 over 1 minus y equals to n start from 0 to infinity, y to the power n. Here, the absolute value of y must be less than 1. طبعا, if it is plus, it is the same. 1 plus y. If it is a plus, I showed you in the previous class that it will be negative 1 to the power n, y to the power n. From where the trick is coming from, replacing this plus by negative, double negative. So this is your tool, ya Shabab. So you can focus on this, and from this you can obtain all others. Just keep focusing on this one. Now, how to use this formula here? This is what I want you to do. So I will choose one of you, Shabab, in an arbitrary way. Let me choose one of you in an arbitrary way. I just keep it for luck, يعني. Leave it for luck. Badr al-Ga'at. Are you here, Badr?
Yes, doctor.
Okay, Badr, tell me what you can do about this.
I think first we should make the function like the law.
Sorry. So how to do that?
I think we factor x out first.
So we
And
take x here
2.
and we write it like 1 over.
And we factor 2
1.
also, doctor, so we can make it 1.
It is 1 already. You have 1 here.
Oh, okay.
Just interchange. You know that the addition is commutative.
Yes.
It is better to do that. Which is, of course, you can do it in one step, but let's do it in 2 steps. It is minus minus. Is that right?
Yes.
So what you will do next, ya Badr? Equals to what? This x is as it is. What is this?
It will become 2 minus 2x to power 2.
Sigma first of all.
Sigma, yes, of course.
Then start from 0 to infinity. Instead of y, just replace this y. Ya Shabab, just please remember this. 1 over 1 minus whatever here. Star. Let's say 1 minus star. 1 minus star. If this star is continuous, it is equals to sigma n start from 0 to infinity for this star, provided that this star is less than 1. Okay? So here what we will have a better negative 2x squared, or this is our star now, to the power?
Yes, n.
To the power. This is the power representation. What is remaining is just a matter of simplifying. So this will be equals to what? If you want to make it much simple, it will be equals to sigma n start from 0 to infinity. Let me keep the x, do one more step. This will be negative 2 to the power n. You can write it, by the way, as negative 1 to the power n, 2 to the power n. It is up to you. X to the power 2n. Then multiply by x in the last step. You can also, as I said, write this as negative 1 to the power n, 2 to the power n. X to the power 2n plus 1. Is that right? Just I multiplied each term by x. Badr, is that right?
Yes, doctor.
Okay, thank you, Badr. This was, ya Shabab, the first part. Find the series representation. Now, the second part, determine the interval of convergence. What is the interval of convergence? Let me choose, select one of you. Let's see who is lucky. Muhannad by Ismail. Muhannad.
Yes, doctor.
Ismail. Yeah, Muhannad, what will be the interval of convergence for this one? Are you here, Muhannad?
I am here.
Okay, what will be the interval of convergence, Muhammad?
Honestly, I don't know.
Okay, let's choose another one. Abdul Al-Jaid. I think this is Abdul Aziz Al-Jaid. Abdul Aziz. Are you here, Abdul Aziz? Abdul Aziz is absent. He's not responding.
Yes, doctor, I'm here.
طيب, do you have an idea, Abdul Aziz, about it?
Can you go back to the question?
Here it is. Can you see the question now?
Yeah, yes.
We don't have much time, Abdul Aziz.
Yeah.
Please, I told you here, ya Shabab. I told you here. Let me repeat it again here. I said, ya Shabab, we have 1 over 1 minus star equals 2 sigma star up to the power n. N start from 1 to from 0 to infinity. This is valid if what? If the absolute value of this star is less than 1. This is the interval of convergence. So for this one, what we will do? Let me choose another one. Khalid Al-Milham.
Yes, doctor.
So what we should do, ya Khalid?
So we put x as 2n plus 1 less than 1 in brackets.
What is our star now, ya Khalid?
Sorry, our star is minus 1 over n.
Negative?
Yes, negative minus 1 to the power n.
No. You are not following. يا محمد يا خالد احنا قلنا هاي تساوي هاي. And this one equals to this.
Oh, yes, I get it. Without the minus 1. 2n. 2n. Multiplied by x was 2n plus 1.
I don't want يا شباب how to say it. يعني يبدو أني فشلت في إيصال المعلومة. يا شباب لما نقول 1 minus y تساوي سيجما y to the power n ضروري الابسولوت فاليو حقت الواي تكون less than 1. هذا الشرط جاي من الجيومتريك سيريز. الآن في هاي look at this and this. What is y؟ ايش الواي في حالتنا؟ ايش الواي في حالتنا يا شباب؟ انتوا الحين يعني math 102 students. I don't know what to say. خالد الملحم
minus 2. Yeah, I think minus 2x was 2.
Yes, finally. So
I try to less than 1.
This is
in
less
brackets,
than 1.
Yes, in brackets.
What is brackets?
Absolute value, I mean, sorry.
Absolute value. الله يرضى عليك. صح. Less than 1. Now ما ودي أسألك how to solve this. أخاف تطلع كمان ما تقدر تحلها يعني. فخلاص. This is an absolute value inequality. This is the absolute value of 2. The absolute value of negative 2 is 2. The absolute value of x squared less than 1. This is the absolute value of x all squared, because you know the absolute value of squared is the square of the absolute value, less than 1 over 2. Now this means that the absolute value of x is less than 1 over square root of 2. What he asked about the interval of convergence. If he asked about the radius, this is the radius. If he asked about the interval of convergence, we need to solve it. So it will be x less than 1 over square root of 2 greater than negative 1 over square root of 2. If you don't know how to solve inequality, you have to be careful. So this is the interval of convergence, x between negative 1 over 2 and 1 over 2. This is the solution. This is the first part, and this is the second part. We spend like 13 minutes on one question. I don't know how we can solve all the problems. Let's go to the next question. Again, find a power series representation for this function and determine the radius of convergence. What is the radius of convergence? So the same idea. I think you can now just keep in mind that your main tool is this. And of course, and the formulas that is related to. Okay, let me now choose. I think you are ready. And I will give you a few seconds to think about it. محمد مصبح.
Yes, I'm here.
Okay, Muhammad, any idea?
I think we expand the denominator.
Then you will make it more complicated, by the way. If you expand, you will have 1 plus 8x plus 16x squared. Then
and then it will be x times 1 over 1 plus 8x plus 16x squared. And then it will be 1 minus 8x minus 16x squared.
Not bad, but it will be complicated. How to do that after that? It will be 1 minus 8x minus 16x squared. And then you will apply it. And I told you yesterday to avoid doing this, because what will be the center? It will be centered at what? You will not be able to find the determinant. If you remember that what I told you yesterday, when you have 2 plus x, I told you you can do that, and you can do this as y, but it will not be centered at 0. So you need to think about in a different way. If you remember, yeah, Muhammad, we said yesterday that 1 over 1 minus x equals to sigma x to the power n, and start from 0. When we differentiate, what we will have? We will have this. We did that yesterday or not?
Oh, yeah, yes.
So you should remember, when you see this square here, you should think about this way.
صح, yes.
So what you should do here, you should start from 1 over 1 plus 4x. 1 over 1 plus 4x. So because just if I were you, what I will do, I will say this is x over 1 plus 4x. I will start from here. I know what is this equals to. What is this equals to, Muhammad? This is equals to sigma and start from 0 to infinity for what? This is 1 over 1 minus 4x.
Oh, yes, yes.
It's much
صح.
clearer. So this is
Yeah,
sigma
yeah. It will be sigma minus 4x to the power n.
to the power n. Now this equals to, you can, of course, you can also write it as sigma n start from 0 to infinity, negative 4 to the power n, x to the power n. Okay, so this is now this one. How to go from here to here? First of all, you need to find what? The derivative. Differentiate both sides. So if you wanted to do that, differentiate both sides. So what is the derivative now of this? If you differentiate both sides, what you will have? The derivative of this will be what? 1 plus 4x all to the power 2, the square of the denominator. Then the denominator multiplied by 0, it is negative. 1 multiplied by the derivative of the denominator, which is negative 4. So we have negative 4 equals to sigma. When we differentiate, we will lose the first term. So we will start from 1. Negative 4 to the power n is a constant. What is the derivative of x to the power n? It is n x to the power n minus 1. Okay. Now, this is not what we want. Indeed, we want x over, but good now, good. We have now the squared. Now, how to get x? We can multiply by what? Let me do something before. Let's divide by negative 4. Is it okay if I did that? So
Yes.
1 over 1 plus 4x all squared. If I divide by negative 4, it will be equals to what? Sigma n start from 0 to infinity. If I divide here by negative 4, Shabab, what it will be?
N
It will
minus
be
1.
negative 4 to the power n minus
1.
1. N x to the power n minus 1. Good. So this is what we have. Now we are very close from what we have, what we want. Just we want to multiply by what?
X.
By x. So I will multiply both sides by x. So it will have x over 1 plus 4x all to the power 2 equals to sigma n start from 0 to infinity, negative 4 to the power n minus 1 times n times x. N minus 1 multiplied by x, it will be n, ya shabab. Because we multiplied, the negative 1 will go with 1. So here we are. So we have now, this is the answer. What we got n start from 1 to infinity, negative 4 to the power n minus 1, and we get here n x to the power n. This is what you obtained. But look at the answer, for example. If in the choices, if you didn't find this, it means that there is re-indexing happening there. So here, if you compare this with this, they are the same. Look at the first term. What is the first term here? If n is 1, what you will have? You will have 1 times x to the power 1. The same if you put x equals to 0 here. You will have 1 times x to the power 1. It is the same. So it is the same series. But it is about re-indexing. So how to do that? You can re-index, but to start from 0, Shabab, you want to start from 0. Just here, look at this. It is n minus 1 equals to 0. So both this equals to n. So m equals to n minus 1. If n is 1, then m is 0. So you have now this series equals to n start from 0 to infinity. Now, n minus 1 will be m, and of course n from here. N will be m plus 1. So here it will be m plus 1. And this will be x to the power. What is n? N is m plus 1. If you compare, if you look at this, it is the same as this. It is just about the index m. It is m or n, it doesn't matter. It is just an index. You can put it k, I, whatever. Is that clear, Shabab?
Yes, doctor.
Now,
Yes, doctor.
the second part is what is the radius of convergence? How to find the radius of convergence, Shabab? Let me go back to the previous slide to find the radius of convergence. I wish that's still there. Yes. Now we applied where? Where we applied the formula? We applied the formula here in this part. Here. So let me choose any one of you to help me with that. Yes, we applied the formula here, Shabab. So now what should be the condition? What is the radius? Let me choose. Muhammad al-Musa. Muhammad al-Musa, are you here, Muhammad?
Yes, doctor.
Yes, Muhammad. What do you think? How to find the radius of convergence?
Can you go back to that slightly? The absolute value of negative 4x, the less than 1.
You are right. MashaAllah alaykum, Muhammad. You are right. So this is our y. Khalas. Now this is 4. The absolute value of x is less than 1. The absolute value of x is less than 1 over 4. So what is the radius of convergence?
1 over 4.
1 over 4. This one is the radius of convergence. Remember the standard formula, Shabab. For the condition is this. So in our case, a is 0 and the radius of convergence is 1 over 4. You are totally right.
Thank you very much, doctor.
Great. Let's now go to the next question. Again, I will give you a few seconds to think about it, and then we will solve it together. Use a power series to approximate the definite integral to 6 decimal places. So we will not focus on the approximation process, Shabab, especially if you need a calculator. But for this one, you can, by the way, do it without a calculator. It is just time consuming. You need more time. So what is our main target is, forget about this. How to find the indefinite integral. How to write this indefinite integral that you cannot, of course, evaluate easily by the usual techniques that you know from chapter 7. So in that case, you can approximate it as a power series, represent it as a power series. So here, what we can do about this. So this is the main part that we want. Then we will focus on that later. This is not difficult. 6 decimal places, this means that it is less than the error. This means that the error is less than 10 to the power negative 6. This is the meaning of that mathematically. When you calculate the exact value minus the approximated one, it should be less than or equals to 10 to the power negative 6. And this, of course, should remind us about the estimating the errors. Now we don't have estimating the error in 11.3 and 11.4, just in 11.5, if you remember. So this means that we expect to have alternating series at the end. Okay, let's keep this for the next part. Now what we want to do is to focus on this integral. So before the integral, to find the integral of this as a power series, you need to think about this one as a power series. What is it equals to? So this is equals to what as a power series? How to represent it as a power series? Let's see who is lucky to solve this question. Abdurrahman al-Fahid.
Yes, dear. Yes, I'm here.
Okay, what we can do, Abdurrahman?
I think we should put it sigma n starts from 0 to infinity.
So you should just
Minus
recall
one.
our main equation.
Yes.
So
is it right or not?
you should first write x squared alone.
Yes, it's
and
alone.
1 over 1 minus
I
x
solve it completely.
Okay, so this will be x squared sigma n start from 0 to infinity for what?
minus x to the power
All to the
4.
power
Yes,
which will equals to what?
which is equal to sigma n start from 0 to infinity minus 1 to the power n times x for n plus 2 to the power x.
From where this plus 2 is coming? From this x squared. We multiplied each
Yes.
term by this x squared. Now we are ready to integrate. Now we have the series representation. So this is x squared over 1 plus x to the power 4. We are ready now to apply the integral. So just integrate both sides. So here what we will do, we will integrate with respect to x. Integrate with respect to x. Now when you integrate with respect to x, you can integrate term by term. So this will be equals to the integral, the sigma of the integral. -1 is a constant. So the integral from for x to the power 4n plus 2 dx, which is clearly, Shabab, equals to what? -1 to the power n, x to the power 4n plus 3 over 4n plus 3. Now this is the indefinite integral. If we are talking about the indefinite integral, this will be from where to where? From 0 to 0.3. If you substitute by 0.3, you will have here 0.3. And when you substitute by 0, you will get 0 plus 0 plus 0 plus 0. So it is 0. It is gone. Here we are. So we left up with this. Let me repeat it again. It is 0.3 4n plus 3 over 4n plus 3. So this is the exact series that is corresponding to the infinite series that is corresponding to this integral. Now we want to approximate the value of this definite integral to 6 decimal places. So now we want to approximate it such that the difference between the estimation and the exact sum will not be bigger than 10 to the power -6. How to do that? Notice that we have alternating series. So because we have alternating series, we will apply the alternating series estimation theorem, if you remember. Do you remember it, ya Shabab? Let me remind you about it, if you forget.
Yes.
If we have S minus Sn, which is the error, it will be less than Bn plus 1. What is Bn? When you have C -1 to the power n, Bn, okay? And it will be less than this one, okay? In our case, we want Bn plus 1 to be less than 10 to the power -6, which is 0.000001. Now, what is Bn plus 1 in our case? If you remember, I think this is the series that we have. I did write the detailed solution for you for this one. Here you are. We stopped here, Shabab. Now this is our Bn. This is Bn. As I said, Shabab, we will not focus on estimation in this section, but just to give you an idea about it. Now we need the Bn plus 1. What will be Bn plus 1? Bn plus 1 will be what? We want the error to be less than this, so we want Bn plus 1. Bn plus 1, replace n. If you replace this n by n plus 1, it will be what? It will be 4n plus 1 plus 3. So it will be 4n plus 3 plus 4 plus 3. So it will be 4n plus 7. Here it is. We want it now this to be less than 0.00. Now you need to think about when n is 0, what will happen? When n is 1, what will happen? When n is 2, and you will see. If n is 0, Shabab, check that, please. I will leave it for you to check. You will have what? 0.3 to the power 7 over 7. This is what? This is equals to 3 to the power 7 multiplied by 3 over 10. It is 3 over 10. So this is 10 to the power negative. This is 10 to the power -7 over 7. 10 to the power -7 is less than 10. This is, by the way, 10 to the power -6. But unfortunately, we have here 3 to the power 10, 3 to the power 7. This also will be a big number. Check that, ya Shabab, please. You will find that it is greater than 10 to the power -6, not bigger than. So now you will take n equals to 1. You will have 3 to the power 11, because when n is 1, you will have 4 plus 4, 7, 11 times 10 to the power negative 11 over 11. And this will be indeed less than 10 to the power negative 6. Okay, so it is n. This means that n is 1. The n that we need to have this error is 1. Then you will just find what? When n is 0 and when n is 1, and you will add them together. So you will not take the how many terms we need to approximate the sum, only 2 terms, n equals 0 and n equals 1. And it will be like this, by the way. If you calculate what is this and what is this, you subtract them, because one of them will be positive, the first one positive, the second one is negative. Subtract them, you will have this. And this is a good approximation for this integral. Let's go now, Shabab, to the question that I gave you yesterday at the end of the previous class, and I have asked you to solve it at home. Who solved it, Shabab? Who solved this question? Anyone?
I tried, Doctor, but I didn't know how to solve it.
No problem. This is what I want you to try. Today we will learn the trick, and we already learned it in the previous questions when we take the derivatives and these issues. But let's see, Walid. I saw Walid raising his hand.
Yes, Doctor.
Do you solve it, Walid?
Yes.
What you did, please tell me.
First we compare to the 1 over 1 minus x.
Again?
First we compare it to 1 over 1 minus x, then differentiate it.
No, how to do that? If you compare it to 1, you mean this equals to 1 over 1 minus x?
No, not equal. Just to
okay, so
يعني أخليها لأقرب صورة لها.
Forget about this for a while. Yeah, Walid. Use what you know. What you know? You know that sigma x to the power n. Let me divide this into 2 parts, if we can do that. We know that x to the power n, when n starts from 0 to infinity, is equals to 1 over 1 minus x. I think this is what you mean.
Yes,
okay?
Doctor.
And the absolute value of x is less than 1. Is this valid if I take x equals to be third? Can I apply it here? Is third is here?
No, Doctor.
Yes. Why no? Why it is not? The absolute value of third, what is it? It is third. So it is less than 1. So I can use this, because all what is coming is depend on this. It looks like you didn't get my point, Walid. If it is a 3, you cannot use this. For x equals 3, you cannot use this one. This is only for x between 1 and negative 1. Yeah, Shabab, this formula is only for x between negative 1 and 1.
Yeah, Doctor, I didn't do that actually. I differentiated and
it will stay as it is. Okay, let me continue.
Yeah, okay.
Now, if we differentiate, we will have n start from where? From 1, right?
Yes. Right.
It will be n x to the power n minus 1. What is the derivative here, Walid?
1 over 1 minus x to the power 2.
The absolute value of x is still less than 1. The same condition is still there, okay?
Then we multiply by x.
Now compare this with this. Compare, ya Shabab, this one.
Still
with
not.
this one. Is it the same or not?
No.
N starts from 1,
multiply
while here it starts from 2. Here we have n, here we have n. Here we have x, so we will think about putting x equals a third. So this is to the power n, this is to the power n minus 1. So what we can do to make it, now let's focus on the power. We need this power to be n, not n minus 1. We can do
by x.
You can re-index, but if you re-index, this will be changed, and this will be changed. So you will have another problem. So what you should do, ya Walid, what you did?
Multiply by x.
Good. To get rid of this negative 1, multiply by x. So if you multiply both sides by x, what you will have? N start from 1 to infinity, n x to the power n equals to x over 1 minus x all squared. Right. We still have the same condition there. Okay. Now, is it the same now or not?
No, we have to have n equal to, not n
We
equal.
started here from 2, but here it is from 1. This is another trick. So what we need to do, what you will do?
To write the first term.
Again, يا شباب, don't use re-indexing. Don't re-index, because if you re-index the series, you will have a problem here or there. So now what we will do, as Walid says, we will put n equals to 1. So if you expand this one, if you expand it, what you will have? 1 times x to the power 1 plus 2x to the power 2 plus 3x to the power 3 and so on. So just write, let the first term as it is, and then what is this from here to the infinity? It is sigma n start from 2 to infinity, x to the power n x to the power n. So what we will do, we will just write the first term of this series, which is x plus sigma n start from 2 to infinity, and this is of course n x to the power n equals to x over 1 minus x all squared. This is valid also for the same interval. Now this is what we want, ya shabab.
Yes.
So now this equals to x over 1 minus x all squared minus x. We move this x to the another side. Now this is for any x between 1 and the negative 1, not only for third. Now let x equals to third. This is what you need to do. Both x equals to third. This will be n starting from 2 to infinity for n third to the power n, which is the same as we want, equals to third over 1 minus third, which is 2 over third all squared, which is 4 over 9. Be careful يا شباب, بعضكم من الفرح ما يصدق انه حل السؤال, يغلط في اخر خطوات ويروح منه السؤال. Be careful. So now replace x by third. You can do it slowly and step by step. 1 minus third, this is third all squared. This is equals to third over 1 minus third is 2 third. 2 third squared is 4 over 9 minus third. This is third multiplied by 9 over 4 minus third. This is 3 over 4 minus third. And this one equals to, as we see in the previous class, it is 5 over 12. Just it is 12. 4 here you multiply by 3, here you multiply by 4. 9 minus 4, it is 5. Great. Now let's go to a problem similar to the tricks that we learned in this exercise. Find the sum of this one, where the absolute value of x is less than 1. Again, this is from the convergent geometric series. Now, how to do that? Notice that we have here n start from 2. And what is this? If you look at it, this is what? Let me ask ya shabab, one of you, to give you a chance also to participate. So, who is lucky this time? Jawad. Are you here, Jawad? Jawad? Jawad is not here. Let's take another one. Nawaf al-Mutlaq. Nawaf, are you here?
Yes, I'm here, Doctor.
Okay, Nawaf. So again, start with what you know, and then use it to find what you want. So we know this. So what do you think? How to go from here to here?
To go from here, we have to multiply by n minus 1.
No, you cannot multiply by n. N is the index.
Yeah, sorry.
Focus on this, ya Nawaf. What is this if you compare this with this?
Yeah, the differentiate, I think.
Yes, now finally you got it, Nawaf. So this is x to the power n, and start from 0 to infinity. This is what we have. We have this. So forget about the condition, it is valid. So this is what we have. Now what we will do first derivative. We will differentiate. This will be n x to the power n minus 1 equals to, what is the derivative of this, Nawaf? And start from 1 طبعا, Nawaf, because we will use the first term. So this will be what? 1 over
1 minus x squared.
All squared.
Yeah.
Now what is differentiate again? We will start from where, Nawaf?
From 2.
From 2 when we differentiate. It will be n multiplied by n minus 1 x to the power n minus 2. This is equals to what? What is the derivative of this? What is the derivative of this, Nawaf? Of this side?
We add 1 to the power.
No, differentiate. Be careful. How you mean you will add it to the denominator?
Yes.
When you differentiate this, it will be equals to what? 1 over 1 minus x all to the power 3. Be careful. You have to do it, Shabab. In fact, it is 2, which is the power, multiplied by 1 minus x all to the power 3.
Yes.
You can do it, Shabab, carefully with the quotient rule. So you will square the denominator, then the numerator multiplied by the derivative of the denominator, which is 0, minus the numerator multiplied by the derivative of the denominator, which is the derivative of negative x is 1. So it will be 2. This will be cancelled with this, and you will have 3. So it will be 2 over this. You have to be careful about the steps, ya Shabab, that depends on your previous knowledge. Again, you can use the formula. There's a formula for that. There's the formula. What is the derivative of x to the power n? Okay. Next, are we done, Nawaf, or we need to do
Doctor,
something?
minus 2, Doctor.
No, the derivative of negative x.
No, we are not done, Doctor. We have to multiply by.
Who said negative 2?
Negative 2 over 1 minus x to the power 3, I think.
You didn't differentiate negative x. The derivative of 1 minus x, it is what? It's negative 1. You forget it. You got it?
Yeah.
So now what we are not done. We need now, this is x to the power n, and this is x to the power n minus 2. So we will multiply by what?
By x to the power 2.
By x to the power 2. So this is n
Yes.
equals to 2 to infinity for x to the power n equals to 2x squared over 1 minus x all to the power 3. Keep this in mind, Shabab. This is what we have in the next slide. Here it is. Okay, so now let's go to the next question, but I want you to remember this. I will write it down here at the beginning. So what we have from part 1, from part 1, we have this sigma n times n minus 1 x to the power n start from 2 to infinity equals to 2x squared over 1 minus x all to the power 3. Okay, now how to use this to find this one. This is the trick. Now the question is find the sum. As I told you, Shabab, we are solving now 5C, 40C. Please solve A and B. Okay, now how to relate this to this, Shabab, to solve it. It's a nice trick. So if
Replace x with half.
If he asks you to find this, assume that we don't know about this. If he gives you this, you need to think about this one first and then go to this. Okay? In fact, this is the same as this, but what is x?
Half.
It is a half, yeah, Shabab. Just do one step. It is sigma n start from 2 to infinity, n squared minus n, which is, by the way, n times n minus 1. It is the same. Take n as a common factor. N minus 1, and this is indeed 1 over 2 all to the power n, because 1 over 2 to the power n is a half to the power n. Now, if you compare this with this, if you look at this, you compare it with this, you can see clearly that it is the same. Just here you have what? You have x equals to a half. It's the same. So what we will do, so by part 1, this is equals to what? This is equals to 2 a half squared over 1 minus a half all squared. This is equals to 2 times 4 over, this is to the power 3. Yes, you're right. This is 1 over 8. Be careful when you do these calculations. It will be a half multiplied by 8. 8 over 2 is 4. So this is equals to 4. This is the sum of this convergence series. The sum is 4. How to do that? You need to work on this with x in general. You need to write it like this, and you realize this x to the power n. Then you work on the derivative until you have something like this. So it is a good question. Good question. Similar to the old exam that we solved. I think even it is more complicated than that one. It is just about the reindexing there. Any question about this, Shabab? Let's go to the last one. So let's keep this result يا شباب. Remember this please. Let me write it down here. So what we have from the previous one, we have this. We have sigma n squared minus n over 2 n start from 2 to infinity equals to 4. This is the previous one. This is part 2. Now find the sum of this one. And now you need to use this part 1. You need to use part 2, which part 2 depends on part 1. So how to do that? You need to think about what is this equals to? This is equals to what? What is the sum? Again, you should think, if you have a problem like this, you should think about this, where x is a half. And start think about dealing with this problem. طبعا one way I solve it for you by one way, and I show you here similar way, but we can start from here شباب. طبعا what I did for you is this. It's just here. What I did for you شباب, I just add n and subtract n. And then because it is convergent, he is asking about the sum, so it is convergent, I can separate. This one I have it from the previous part. This one equals to 4 from the previous part. What is the problem here is the starting. Here we want to start from 1, but indeed in the previous example or part 2, we started from 2. So indeed, if you look here, 1 minus 1, if you put n equals to 1, what you will have? 1 minus 1, 0. So it is 0 plus start from 2. So it is the same. This one is the same as this one. Because if you start from 1, you will get 0. 0 plus, خلاص, it is the same. So you can replace this by this. Because the first term is 0. Okay? Now, as I said, this is يا شباب from part 2. This is this 4, and we will continue. Or you can do what I told you. You can start from here. You can start from here because it is convergent. You can separate again because we have started from 1. We can start from 1 because it will be 0. If you put n equals to 1, it will be 0. So you can write it this way. It is the same. Then you can separate. Start from to infinity, n squared over 2 minus n over 2 equals to 4. 2 to the power n, 2 to the power n, 2 to the power n, 2 to the power n. I forget that. Now, this is what we want. So it will be equals to 4 plus this. N start from 1 to infinity. So the question is, what is this? So this is exactly now the same as we have here. We stopped here. Now, ya shabab, who can tell me how to find this? It is so easy. How to find this? I think now you learn the tricks. Anyone other than Walid? This is ya shabab equals to n start from 1 to infinity. When you have n start from 1, you should think about the derivative. This is n multiplied by a half to the power n. Is that right? What I did, I just write instead of 1 over 2 to the power n, I write it like a half to the power n.
Yes.
Now, it looks like the derivative, so you need to think about this, x to the power n, but unfortunately we don't have minus 1. So what we can do, we can take x out, okay? So we can write this as sigma n start from 1. We can take a half out, factor it out. N a half to the power n minus 1. It is the same. Now this is the derivative. I told you, and you know from before, that n x to the power minus 1, when n starts from 1 to infinity, it is derivative. It is 1 over x minus x squared. So this will be a half multiplied by 1 over 1 minus a half all squared. And this is, of course, you can now evaluate. This is a half multiplied by what? 1 minus a half is a half. A half squared is 1 over 4. 1 over 4 it will be 4. 4 over 2 it will be 2. So this is equals to 2. Not this one. This one equals to 2. And this will be 4 plus 2. It will be equals to 6. This equals to 6. That's it, ya shabab. This is all what we have for today. And I will put the solution for this one for you because I was thinking, I was afraid that we will not be able to solve it. The time will not allow us. But we are lucky we solved it completely. I was preparing some old exam questions for you to be solved. Inshallah, we will do it next week if we have time to review the materials of chapter 11. Thank you, Shabab, and see you inshallah on Thursday.